Alright, so I've cashed out the new sim and run a flipbook of the sim. So if we play this, it looks pretty cool. I think it still needs some breakup in this beam, but that's something that I'm going to deal with later. And another thing that we should get into is, since I have this sim and I think that this is fanning out too far, we don't need to resim, we just need to cull what we have right now, and we can do that using nage. So I'll show you how to do that real quick. So let's go to something like this that's way too many particles fanning out. So we'll do a pop, no, a point wrangle. And so one thing that is stored, you won't see it in the geometry spreadsheet, but it does exist. It just, for some reason, doesn't show up. Is we can use nage, and I can do that. You can visualize it by just setting the color to nage. And there you go. You can see that it goes from 0 to 1 from a life of 0, and white as it reaches the end of its life. And so what we can do is something like this, where we can say if nage is greater than, and then we'll just create a channel. So cull age we can say remove point, and so then we do 0 for the input 0 and corresponding point number. And right now, if anything is greater than 0, it gets removed, which we definitely don't want that. But now I can start moving this up, and we can see, oh, while that is too much, we can just dial it in to something like that, which is far more manageable. We're not getting quite as much ground interaction, but that's okay. It was fanning too much, and let's say we wanted to kill it even more, we could just do that. So it's okay to have too many particles. I'd much rather have too many than too few, because while you can do point replicates, it's never as good as having the amount of particles that you actually need in a sim. And it's pretty easy using nage to cull out as much or as little as you want. So yeah, too much there, but let's say something like that should work for now. So now that we have the shape of the beam looking pretty good, now we're going to start messing with the render of the beam. So we're going to rasterize these particles to get a volume, and then we're going to create a color from that volume to give it more of an actual beam look instead of just a flip-like particle sim. So the first thing that we're going to have to do is create another point wrangle. I don't really like to do too many operations in one point wrangle. For example, here I'm culling out things with nage, but I don't want to add on to this. I want to create another point wrangle so that I can easily go between the operations, and if one thing I think needs to go away, I can just delete that wrangle rather than going in and trying to hunt down the code. Also, it doesn't hurt to be naming all of these things. I don't generally do it too often unless I'm passing it off to someone else. It is good habit though. However, for this tutorial, I don't really think it's necessary. So, what we need to do now is we need to give each particle a p-scale. So we're going to just do p-scale equals fit01 rand id. Now that we have IDs from these particles, we're going to use those. Previously to this, that we've been running it over a point number, but since the particles live and die, the point number is going to change frequently. So we just want to run it over the exact ID of each particle so that whatever p-scale we give it doesn't change over its lifetime. So I'm going to do a min and a max as we have been doing. And so these particles are going to need to be pretty small to start off with. So we're gonna do something, let's make this something like that for now. So another thing we're gonna need when we're rasterizing these particles is an alpha. And we're just gonna set the alpha value to 1 right now. And next we're gonna have to set up some values using a pyro source. So this is going to set it up so that when we rasterize it, it knows what to do basically. And so this is good. It's going to keep the input. We're going to create density, temperature, alpha, and color. Actually, we're also going to add velocity. That way we'll have motion blur. And so all of these can stay default except for I usually have to mult up the density. I'm going to do it to 15. It's pretty large value right now. We'll see what happens. Might not work, but it should be good. So now we're going to do a volume rasterize attributes. So that's going to take everything that this pyro source is set up, and so first we have to define the attributes that it's going to rasterize. And it's going to make a volume per attribute that I create here. So I'm going to say density, I'm going to say temperature, color, alpha, and velocity. So right off the bat, this is very thick. We don't want it to be all that thick, and we also want the resolution of this volume to be much higher. So we're gonna make that 0.1. It's gonna have to think about it for a hot second. And then we want to reduce this particle scale by a significant amount, so I'm going to make it 0.15 for now. I'm going to take it down to 0.1. So that's looking pretty cool. One thing that it's going to need though is velocity blur, and that's why we have that velocity attribute. And so now when we do this, it's going to fan everything out and make it look like it's actually stretching and reacting in the world. So okay, that's looking pretty interesting. But now that we have our rasterized particles, one thing, I think I am gonna make this a little bit higher res. You always want to go in really small increments, otherwise you run the risk of bombing your box. That's not very fun. So I'm going to make this a little bit smaller. That should work. Okay, so what we need to do now is we need to change the color of this. And in order to do that, we're not going to use a point wrangle, we're going to use a volume wrangle. So first things first, we are going to change the color attribute, and we are going to take we need to create a ramp. So we're going to do ch ramp. I'm going to name the ramp color ramp. And we need to alter the color. Now normally this makes a spline ramp, but if you define it ahead of time and say that it's a vector, it will create an RGB ramp. So let's do that. And now we can start playing with the color of our pyro. So I'd say first thing, we'll make the inner core, or inner and outer hot. We're going to make that Let's make this a deeper orange. Orange red-ish. Then we're going to... The good guy, he'll have sort of an orange beam. Get a little gold in there. Flip these around. And we'll make ourselves a happy little beam. So now you might be thinking, wait a minute, this doesn't have any color at all. And right now it does not, and it's not going to show up in the viewport. So first we have to, I'm going to name this something. So this will be beams. And we're going to go into the out context, create a mantra node, and we'll do hero beam. I don't use candidate objects, I always force, and we'll do that. We'll use action cam to render, and I'll up the pixel samples to 6. Keep it on ray tracing. We'll go to our render view, and let's see what we got. And there you have it. Now we have some color in our beam. Granted, it's a little dark at the moment. We're going to have to play with the color values a bit. Also, there's no actual lighting information in the scene, so that might have some factor to it. But another thing is it does not have a material at the moment, so that will also make it not very emissive. So we can give this a shader. We'll go to the material palette. I always just use a basic smoke. And now if we go here, we'll go to the matte net. We're going to change this to hero beam. We'll be splitting each beam out, but for now we're just going to render out of the beams. And so then now what we need to do in the material is it's looking for the fire intensity, the dense, and so all this stuff here, it's looking at these fields that aren't actually going to be what we're using. We're going to change everything to look at the density. And I'm going to make sure that this is using velocity blur. And there we go. So now this is way hotter. It's emissive, but it needs to be dialed, obviously. And that's not too terribly hard. We can go into here, and where intensity scale and temperature scale is, we'll just start playing with these. We're going to tint smoke color with CD. We're going to use color field, and there you go. So that looks a lot closer to what we were looking for. We're going to need to play with the color ramps a little bit. I don't love the dark orange that's there, and I think things should generally be kind of inverted so that the hotter stuff is by the core. So we'll just kill the render for a second and do maybe something like this. Make this a little bit more golden. Yeah, let's try this out. So now we can see that it's too hot in the core. There's a lot of density in it, so since it's using density instead of temperature or heat, there's a lot of density going on in the core, so we need to play around with these values a little bit. Do something like that. Tighten it so that only the most dense part of this beam is white. So we'll just start dialing things back a little bit. Now you can see as I move this farther into the core values, yeah, it starts to spread out a little bit. Now we've gone a little bit too orange, so I'm going to make this the very tip. And then maybe start doing something like that. One quick thing that I noticed that I'd like to fix without having to go back into the sim right now is if we look at this render, we can see a lot of these little flyaway guys. These little bits that look like particulates and less like a beam that's crashing. We want most of this to be contained within a nice volume here. So there's actually a pretty quick way to isolate things that have been sort of orphaned and flying off away from the larger majority of the particles. So I'm going to go set that up right now. And to do this, we are going to do another point wrangle. And we're going to add this in here. And so first thing we're going to have to do is a point cloud lookup. So all that's really doing is each particle will then look in a radius around itself to look at information about the particles surrounding it. So first we're going to define our handle for the point cloud. So we need to do it. We're going to just create an integer. I'm just going to call it lookup. And we're going to do PC open or point cloud open. And so then I want to look at the particles within this geometry, so this handle. So then it needs to know the position, and then it needs to know the attribute that we're looking up, which I'm just looking at the position of each particle. And then we need to define a float for the radius of how far we want to search. And then we need to create an integer that is the maximum number of points that it'll look up, because we don't want it to look up every particle in this sim. We just want to look at its nearest neighbors. So we'll do max points. Let's see if we have errors. Nope, no errors. So now what we need to do is we're going to do an if statement, and we need to know first the number of points found within the radius of this. I first need to create the channels though. And so the radius, we don't want to look too far out from each particle. We need to look relatively close. There's going to be enough particles that if we want to kill the stranded ones, we only need to look directly around it, and if there's not, let's say, 5 to 7 particles near it, then we want to kill it. So we'll make the radius 0.1 and the maximum points, let's say, I'll start with 7. Let's see what happens here. So then, after we do that, we need to, again, do our if statement. So PC num found, so this just looks at the point cloud and the handle of the point cloud that I've created. So we're going to do lookup. So now it's looking at that PC open, and now it'll tell me in this num found function, I can say it'll return the number of points found, and I want so that if, let's say, it's less than, well, I'll just create, let's say, so we need an int max points. Nope, not max points, because we already have that. Num points. Remove points. So this will remove anything that has less than a certain amount of neighbors. Remove point. So let's just take a look at what this is doing. We can see some of these particles over here. I'll turn it off and see what the difference is between the things that we're killing and the things that we're not killing. Alright, so this gets rid of a lot of the stray guys. But we could probably do a little bit better. So let's say number of points if there aren't points in this radius, then it'll get rid of them. And we need to lower the radius to, let's say, 7.5. Still not getting much. Oh, that's because it's killed. There we go. So yeah, now that it's looking closer to itself, and if there aren't a whole lot of particles near itself, then it's going to get removed. So then this gets rid of all these strays. Perfect.